Hi, Mr. Calix here from Math Magicians, and we will continue with our geometry course. Today we will see points, lines, and planes. Points that lie on the same line are called collinear points. And we have our first example. It says letter A, are points F, P, and C collinear? Okay, first let's locate those points. We have F here, we have P here, and we have C. As you can see, F and C, yes, they belong to the same line M, but P belongs to that line L. That means that they are not collinear. We're going to write as an answer for letter A, no. Letter B says, name line M in 3 other ways. We'll make letter B here. So he says to name it in 3 other ways. We'll name it as E, F. Your answers may vary here. We can also name it as F, C. We can name it also as C, E. Okay, here we're talking about line M. Now, letter C says, why do you think arrowheads are used when drawing a line or naming a line such as EF? The answer is here. They are used to show that the lines extends in opposite directions without end. Let's continue with the next type of exercise. It says, a plane is a flat surface that has no thickness. A plane contains many lines and extends without end in the directions of all its lines. You can name a plane by either a single capital letter or by at least 3 of its non-collinear points. Points and lines in the same plane are coplanar. As you can see, we have planes here, and these points are coplanar. They can be named as one whole point, as plane P, or they can be named as plane ABC. Then exercise 2 says, list 3 different names for the plane represented by the top of the ice cube. In this case, this top of the ice cube. So we're going to name those planes as H, E, F. We can also name it with all the letters H, E, F, and G. Or we can name it as F, G, H. Okay, your answers may vary here, as I said at the beginning. Then we have a postulate. It's an accepted statement or fact. We have our first postulate. It says, through any 2 points, there is exactly 1 line. That means that every time you see through 2 points, there is exactly 1 line that passes through them. Postulate 2 says, if 2 lines intersect, then they intersect in exactly 1 point. There is a similar postulate about the intersection of planes, but a plane says that if 2 planes intersect, then they intersect in exactly 1 line. So 2 lines intersect in exactly 1 point, and 2 planes intersect in exactly 1 line. With that, we're going to answer exercise 3. It says, name 2 planes that intersect in BF. Okay, BF is our line here. And as you can see, we have this plane as an intersection and this plane as an intersection. So we can say that is plane ABF and plane CBF using the line of intersection. Let's continue. Postulate 4. Through any 3 non-collinear points, there is exactly 1 plane. Now, every time you see 3 or more non-collinear points, there has to be exactly 1 plane. So in exercise 4, letter A says, name another point that is the same plane as point ABC. Let's locate ABC, which is the other point that is in the same plane. As you can see, it would be point D, so your answer is D. And in letter B says, name another point that is coplanar with points EHC. That means that it has to be in the same plane. As you can see, EHC is an inclined plane here, and the point that we're missing for that inclined plane would be point B. That would be it for this topic. Thank you for watching, and don't forget, math is magic.